All right. So we're going to look at this question. Two machines in a factory produce electronic components. Machine A produces 400 components each day, with an average of 0.5% being faulty. Machine B produces 600 components each day, with an average of 0.75% being faulty. Component is chosen at random from the combined daily output and found to be faulty. Find the probability that the component was produced by machine B. Give your answer correct to two decimal places. What can be tricky about this type of question, I think, is setting up the correct conditional statements in your notation. So let's be clear about that to begin with. So let A be the event that the component is from machine A and B be from machine B. And F, as you can see here, is going to be the condition that it's faulty, and F dash is that it's not faulty. Okay, so the probability that it's from machine A is just 400 out of 1,000, which is 0.4. Probability that it's from machine B is 600 over 1,000, which is 0.6. Okay, this is where it gets tricky. The probability that it's faulty, given that it's from machine A, and in my mind, it's a little bit tricky to tell the difference. Are we saying that it's faulty given that it's from machine A? Or it's from machine A given that it's faulty? So I think that you just got to be very careful with the wording there. This 0.5% is saying it's faulty given that it's from machine A. So we're going to say that that's 0.005, which is 0.5%, and faulty given it's from machine B is 0.75%, which is 0.0075. Okay, what we're going to do here is we're going to find the probability that any randomly selected component is faulty. We use the law of total probabilities. So the probability that it's faulty is the probability of F given A multiplied by the probability of A plus probability of F given B multiplied by the probability of B. And that gives you this, which is 0.065, sorry, is 0.65% or 0.0065. And that should make sense. Another way you could have calculated this is just by sort of doing a weighted average of the faulty components. So you basically work out 0.5% of 400 and 0.75% of 600, work out how many faulty components there are out of 1,000, and then obviously divide that by 1,000 to get it as a percentage. Anyway, you get 0.06, you get 0.0065. Okay, then this is what we're interested in. Find the probability that the component was produced by machine B. So it's from machine B, given that it's faulty. And then we apply the conditional probability rule, which says, okay, that's the probability of faulty given that it's from B multiplied by the probability of B. Okay, that's, if you're thinking about it as a tree diagram, you're basically going down this branch from machine B and then faulty given that it's from machine B. So you've got, this is essentially the event that it's from B. When you multiply this by this, it's the probability of being from machine B and being faulty. And then you divide by the probability that it's faulty, which we just worked out is 0.0065. So we end up with a situation where we might multiply 0.0075 by 0.6 or 6/10, and then you divide it by 0.0065. And that gives you approximately 69%. So the probability that it's faulty, sorry, it's machine B given that it's faulty is 0.69. Hopefully that clarifies that. I find these questions quite tricky, but hopefully that helps.